Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast we call Space Nuts. My name's Andrew Dunkley, and joining me from the Australian Astronomical Observatory is Fred Watson. Hello, Fred.
Hi, Andrew. How are you going?
I am quite
Here we
well.
are again.
Yes. Now, just a word of warning, there may be interruptions. There's a guy outside Fred's house who's decided he wants to fix his car's engine. And there's a bloke outside my establishment at the moment trimming the hedges. And I mean,
I bet they're in cahoots, you know.
I'd say they rang each other and said, let's get these blokes.
Yeah.
So we could have some not so interstellar interruptions today, but we'll just press on. Now today, Fred, we're going to take another look at Muamua, the interstellar asteroid, because they've discovered even more that makes it interesting. And from that, we go to a snake in space. I heard of pigs in space, but snakes in space... no, but here we go. And finally, we're going to look at this planet that's recently come to light, Ross 128, I think, or that's the star, I'm not sure which, but it's an interesting planet because it's just right. And when we say just right, it's in a vicinity which makes it Earth-like. That's to come, but let's get back to Muamua, and we've talked about this a couple of times already. The asteroid discovered by Pan-STARRS in Hawaii. What's changed? Is there something new to report?
Yes, there is. That's exactly right, Andrew. So when you and I spoke about this the last time, I think we kind of ended on the note that yes, this was now known to be the very first detected interstellar asteroid flying through the solar system. They're probably doing it all the time. I think the estimates are at least one a year, but it's, you know, these things whiz through the inner solar system and they're quite distant, they're small. This one is the first one that was detected. So we talked about it, but I think we left the conversation on the grounds that other big telescopes will almost certainly have been studying this. And we don't yet have their results. Well, now we do. So just let me revisit the chronology. This object looped around the sun. That was its closest point to the sun on the 9th of September. This is 2017, of course. Passed by the Earth on the 14th of October at a distance of about 200 million kilometers, which is kind of, you know, about halfway to the moon. It's not a close miss, a near miss or anything, but it's still within the Earth's vicinity.
Yeah.
And was not picked up. I think the first observation was 5 days after that. I think it was the 19th of 19th of October. That's when Pan-STARRS detected it, and they tracked it, discovered that it was in an orbit that can only have come from outside the solar system, and of course then alerted the world's astronomers. And so what we're seeing now, a month or two later, is the the results, the scientific results from the battery of telescopes that actually were used to observe it. And they included, Andrew, the European Southern Observatory's VLT, the Very Large Telescope, or one of the 4 component telescopes of the Very Large Telescope. Each of these, by the way, with an 8.2 meter diameter mirror, so they are the biggest class of telescopes in the world. Yeah, so the VLT observed it as well. And now we know more about it than we did before. There's a very nice piece about it on the European Southern Observatory's news page. That's a very easy thing to find, www.eso.org/public. That takes you to their public news pages, and there's a press release there whose headline is, ta-da, ESO observations show first interstellar asteroid is like nothing seen before. There you go. They don't come any better than that.
So when they say like nothing seen before, are they talking about the shape or the makeup or the fact that there's someone on top of it waving? What are they talking about? That's
the bit they didn't actually mention that bit.
Funny.
I guess the most striking thing is that it is so elongated. This thing is 10 times longer than it is wide. And that's why it's being, some of the news headlines say, refer to it as the interstellar cigar, the spinning space cigar.
I thought of something else.
Look, I thought of a few things as well. Actually, to be honest, the thing I thought it looked like was a French loaf.
A baguette, the space baguette.
The space baguette, exactly. Yes. A long one, yeah.
No, I'm thinking space doogie. I'm sorry, but that's what it looks like.
I knew that's where you were going. I'm just, ladies and gentlemen of the Space Nuts audience, please give me credit for at least trying to divert him away from that.
I couldn't help it. Oh boy! But anyway. Now we know what it looks like. Why does it look like that?
Well, and I have to look as a postscript to that. I think it is definitely not the colour of a French loaf. I have to say, it's dark and it's reddish, and these are all parameters that come from detailed observation. So how do we know it's long and elongated? Because it's tumbling. It's basically spinning around once every 7.2 hours, if I remember the figure correctly. No, I've got it wrong. It's once every 7.3 hours. Just over 7 hours, it turns end over end. It is something like 400 meters long. So it's a sizable asteroid. But of course, that means it's only 40 meters wide or something. So it's a very long, thin thing. And that's the issue. We've never seen anything like this before. The asteroids that we have managed to image, and that's been done either by spacecraft rendezvousing with asteroids, or you can actually make radar observations of certain asteroids from Earth using dishes like the Arecibo dish in Puerto Rico. So, but they either look like a rubber duck. If you remember the comet that we talked about, Comet 67P looked like a rubber duck. Churyumov-Gerasimenko, to give it its proper name, because it's basically two blobs of material stuck together. That's a common look for asteroids as well. There's asteroids that have a similar appearance. There are asteroids that are kind of potato-shaped, slightly elongated, a bit potato-like, which I suppose is a less extreme form of shape than what we're seeing here with the interstellar asteroid, who, as you correctly said, is called Oumuamua, and that is a Hawaiian name meaning the first visitor from afar. And that's exactly what it is. So how do asteroids get to this shape? And I think that is something that will have all the planetary and asteroid scientists scratching their heads at the moment, because we can kind of understand how asteroids attain these slightly, potato shapes or dumbbell shapes, as some of them are as well, and rubber duck shaped. That is usually a product of the process of what we call accretion. It's the way asteroids are made, by dusty material coming together under its own mutual gravity, and basically it eventually sticks together and you get bigger objects being built. But to make something shaped like a cigar is really, I think, a challenge for the theorists who look at how these things are put together. It has to be said, and this is me thinking kind of outside the box a bit at the moment. The thing that we've based that estimate of its shape on is the light curve, as we call it, the way its brightness varies as it tumbles end over end. But there could be a different explanation. It could be an object that is fairly fairly even in shape, maybe potato shaped. That's got one side very, very much darker than the other, because then you get something similar. You get a change in brightness. I'm just throwing that out in case any space scientists or planetary scientists are listening to this, because even though I gave a talk at a planetary frontiers workshop last week, I'm not really a planetary scientist, in terms of the research that I do. So that's a possibility. The other thing, just to cover this off, it is reddish in colour, as you heard as we discussed in the intro, and that's not new. We've looked at some of the colours of the very distant asteroids, the icy asteroids out beyond the orbit of Neptune, what we sometimes call Kuiper belt objects, because there's a belt of things which was predicted by Gerard P. Kuiper back in the 1950s. That belt sits beyond the orbit of Neptune. There are lots of objects in there. The best known of them is Pluto, but there are others of a comparable size to Pluto. Some of which are very red in colour. I've got a feeling that there's one called Sedna, and I think that is one of the red ones. And the thinking there is that what you're seeing is a surface that is icy, and we know that Pluto has an icy surface, but it's been modified by long-term bombardment with cosmic rays. Now, cosmic rays come from galaxies, actually, rather than, they're not the solar wind or anything. These are subatomic particles that come from galaxies and sometimes quite energetic events in the universe. When they bombard an icy surface, they produce chemicals that give it a reddish color, and that might be the reason why Oumuamua has a reddish color, because it's been flitting through the galaxy possibly for 1 billion years or more. We have no idea how long it's been going. We know that it came from the direction of the bright star Vega. That's in the constellation of Lyra. But the fact is that if you kind of track it back, the length of time it would have taken to get from Vega to here, which is about 300,000 years. Vega was actually in a different position then, so it hasn't come from Vega. It's come from somewhere else.
That will disappoint Jodie Foster.
Almost certainly, yes, that's right. Well, we're always a disappointment there, so that's nothing new. But look, it's surrounded by mystery. It is very exciting, and I guess the best news that we've got from this is that it has been detected at all, because, as I said, people estimate that there's at least one of these things flies through the solar system every year, and we can now look for them with a little bit more hope that we'll find them. They'll be detected, as this one was, by the near-Earth asteroid programs. These are telescopes that are monitoring space, looking for objects that could collide with the Earth. So in a sense, that's our kind of space guard, and these things no doubt will be picked up in the future. I think it's a great thing. I'm not surprised we've talked about this 3 or 4 times, because it's such a good story.
Yes, indeed. And it's really good that ESO went in undeterred. And they're flushed with success. And I do have another theory, Fred.
Do I want to hear it? Really?
Probably not. Given its shape and its colour,
yes,
I think it came from the Baal Nebula. That's what I think.
God.
But
it's like talking to my kids, Andrew.
Dear. We'll leave it there. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, in these last few seconds, we've managed to collect ourselves, and we're going to look at something that's not dissimilarly shaped to what we were just talking about, a cosmic snake. Now, I'm guessing this is some kind of thing in the cosmos that they've looked at that looks like a snake, but it's probably something very unlike a snake in real terms.
It is, yeah. Just as an aside, Andrew, do you know what we've talked about this, the asteroid looking like a cigar and this thing looking like a snake.
You said it looked like a cigar.
I did, yeah. I did say that. You said it looked like something else. Yes. But that process is called pareidolia. Have we spoken about that before? Pareidolia is the human tendency to look at things and say, oh, well, that looks like a whatever it is.
Yeah, like clouds that look like rabbits and things like that.
That's right, all of that, yeah. That's the phenomenon of pareidolia.
We always have to do that, don't we?
We do. We do. That's right. So we're going to continue doing it because this, as you quite rightly said, the cosmic snake is definitely not a snake, and in fact, it's not even a real entity. What it is a distorted image of a real entity, and this goes back to something that we have talked about before, which is gravitational lensing. Yes. You got it in one. That's right. So if you've got a very large mass in the universe, and the largest masses are galaxies that cluster together. So if you've got a cluster of galaxies, and there are many of them out there, what that does is, like any mass in the universe, it distorts the space around it. But clusters of galaxies, being the biggest things around, distort space more than anything else. I mean, the Earth distorts space, but not by very much. No. But a cluster of galaxies really starts bending both space and time, actually, in such a way that it acts like a kind of magnifying glass of anything behind it. And that's how we know about some of the most distant galaxies in the universe, because we use the natural telescope. If I can switch, switch my optical analogies here, these things. Yes, they do act like a magnifying glass, but in the way that makes them resemble a telescope. What they do is they magnify the distant objects behind them. And those distant objects themselves are galaxies. As I said, some of the most distant galaxies we've ever observed have been seen through the telescope of a foreground cluster of galaxies. And that's exactly what's happened here. These observations are really very remarkable indeed. This is a cluster of galaxies in the foreground, which in the midst of them is this image that looks exactly like a snake.
Yeah, it looks like something you'd see on a game of snakes and ladders. or as I think some people in the world call it, chutes and ladders or something like that. But that's what it looks like.
Yeah, it's a snakes and ladders.
And it's a big one too, so it takes you back to start.
Right back to, it's square 5, I think you go back to.
That's right.
That's the thing. These are Hubble Space Telescope observations. So what is it? Well, it is an image of a distant galaxy behind the cluster. Exactly what we've been saying. It's a naturally magnified image of a distant galaxy. But actually, because clusters of galaxies that, the gravitational lens that they form is not a perfectly smooth and regular lens like a magnifying glass. What we're getting here is, I think it's 5 separate images of this distant galaxy, which are all kind of joined together in a line. So because scientists are clever people and have equipment like the Hubble Space Telescope, which has got the wherewithal to disentangle things like this, the details of those 5 separate images have been studied now. And so what we've got is almost, it's like 5 different views of the same galaxy, because the lens is bending the light in such a way that you're finding these 5 separate images. And even though they're all strung together and it looks like one very long and strange thing on a snakes and ladders board, it is actually these remarkable images of a very distant galaxy. Now, I know that the galaxy itself is, it's a young galaxy, because we're seeing so far back in time. I can't actually remember the exact distance, but it's, in the region of 11 billion light years away, something that is, we're seeing it as it was when the universe was young. There's profit to be gained in terms of scientific knowledge by studying this thing closely. And one of the things that has surprised people is that in early galaxies, the galaxies that we see in their youth, you see clumps of star formation, clumps of the galaxy where stars are being born, because these were very energetic galaxies. They were birthing stars at an enormous rate, much faster than, for example, our Milky Way is doing today. But these things were big. They were, 4,000 light years across. And that's really sort of has puzzled astrophysicists, because you imagine in these early galaxies the clumps of star formation would be smaller than that. There'd be clouds of gas and dust where stars are forming, but they wouldn't be as big as 3,000 light years, which is enormous. So the story that's the kind of the backstory of these observations of the cosmic snake is that because we've got this lovely magnified image of this snake by the gravitational lens, we can actually see the detail of star-forming regions within the cosmic snake. And it turns out that what you're seeing, yes, it looks at first sight like something 3,000 or 4,000 light years across, but it's actually made of lots of little ones close together. So it's a kind of optical illusion. It's resolved an issue that cosmologists, the people who look at the history of the universe, have struggled with. Because we see that, yes, these do look like big star-forming regions, but actually there are lots of small ones close together. And that's an interesting outcome.
Yes, it is. It also indicates that our observations of the universe from Earth have always been, in some cases, warped, because we were seeing things that weren't really what we were seeing, and now we're learning more about what's really happening out there.
That's right, and that is true of so many different phenomena within the universe, Andrew. Even starting from the fact that we know we're on a moving planet that's spherical. It looks, to all intents and purposes, when you look outside your window, as though you live on a flat Earth, but of course we don't. And it starts with that, and it goes to things like these gravitational lenses, which are the tricks of the light, in a sense. It's close to my heart, is this, because about 20 years ago, I planned to write a book called Cosmic Illusions, which was exactly about what you've just said, the fact that when we see the universe, we are kind of duped in a way, because the naive interpretation of what we're seeing is quite different from the reality. There are places, for example, where we see things that look as though they're traveling faster than the speed of light, but we know that they can't do that. And when you look at the physics, it turns out that no, they're not traveling faster than the speed of light. It just looks as though they are. So it's stuff like that. I think it's a fascinating aspect of our science, and maybe one day when I get a bit more time, I'll go back and write Cosmic Illusions.
That would be nice. I actually got overtaken by a guy who looked like he was travelling faster than the speed of light the other day. Never saw him again.
No, that's right. Well, you probably won't either.
Where's the police when you need them?
Yeah.
This is Space Nuts. You're listening to Fred Watson, and I'm Andrew Dunkley.
0G, and I feel fine.
Space Nuts.
Finally, Fred, we're going to look at a nearby planet. It's not in our solar system, but it really, in terms of the size of the universe and everything, it's pretty darn close. A temperate Earth-sized planet, 11 light years away, and the beauty of this one is that it is in the right place to be, livable by the sound of it.
That's right. This is once again a really interesting story, which actually has also come from the European Southern Observatory. We're going to hear more and more, by the way, Andrew, from the European Southern Observatory, because Australia is now a strategic partner with them.
Yes, I remember us talking about that, and they're doing some amazing things.
Yeah, they are fantastic stuff, and it's a great, it's a privilege really in the sense that Australia now belongs to a European organisation, but running the best telescopes in the world. One of the instruments that they have at ESO is a thing called HARPS, and HARPS has been going probably for the best part of 20 years now. HARPS is an acronym for High Accuracy Radial Velocity Planet Searcher, and that tells you all about it. What it tells you is that it's looking for planets around other stars, and it does it by what we call the Doppler wiggle technique. As a planet goes around its parent star, it pulls the star very slightly to one side and the other as it's going around, and that causes the star itself to have a velocity which we can detect from Earth. We call it the radial velocity. It's the speed along the line of sight. So HARPS has done a fantastic job with discovering new planets, and this one is its most recent triumph. It is a planet around a star, as you said, with the fancy name of Ross 128. So this is called Ross 128b. You always start with B for planet names. Don't know why we don't get an A. A is probably the star itself.
I was going to say that, yeah.
That's right. Ross 128b is a low-mass planet. That means it's sort of similar to the Earth, goes around its parent star every 9.9 days, so that's their year.
Wow.
Pretty short, really. But that, of course, implies that it's much closer to its parent star than we are to the sun, and indeed it's about 20 times nearer to its parent star than we are to the sun, but it doesn't get fried. And the reason for that is that
it's a cooler star.
It's a cooler star. Ross 128.
It's a rock music star.
It is so cool,
very cool, that
we give it a special name. It's called a red dwarf star.
Aha.
And red dwarfs are actually the commonest stars in our galaxy. Indeed, the planets, the exoplanets, which is a planet going around another star, the one that holds the record as being the nearest is also going around a red dwarf star. That is Proxima Centauri b. Proxima Centauri is the nearest star to the Earth. It's 4.2 light years away, apart from the Sun, of course. The Sun's the nearest star to the Earth, but this is the nearest other star to the Earth. 4.2 light years away. We know it has an Earth-sized planet going around it, but the difference is a critical one, because Proxima Centauri, which holds the record at 4.2 light years away, the nearest exoplanet, the parent star, Proxima Centauri, is actually a pretty normal red dwarf, which means it's a bit violent. It's got solar flares that spit out subatomic particles and basically bombard anything within their vicinity with these subatomic particles that could be quite detrimental to the idea of any living organisms form. Right. And that's where Ross 128 wins out, because Ross 128 is basically a very benign red dwarf star. It is what is called, wait for it, a quiet star. It doesn't have these bursts of high energy particles bombarding stuff. So it's possible that Ross 128b, the planet, as well as being in the temperate zone, the habitable zone around the star, which is where liquid water can exist, it's possible that it's also one of the most benign radiation environments that we know. There's one final twist to this story, which I like very much, and that is given the movement of Ross 128, the star itself carrying its planet along with it, it's actually heading towards us.
Ooh.
And eventually, and it's not very far down the track, you can put this in your diary, 79,000 years away, it'll be nearer than Proxima Centauri.
Gee, that's fast. That is really fast when you think about it.
It's really fast, yeah. It's just a flash, it's just zipping through space. So in 79,000 years, I'm not sure that you and I will be talking then, but hopefully somebody still will. It will be the nearest habitable world to our own in terms of its, it's a kind of record-breaking status. So, the closest exoplanet to Earth in 79,000 years. It may even be worth making a trip there. Who knows?
Well, by then, I would think we probably would have sorted out some of the problems of interstellar travel.
Travel, I think so. We'll either be gone altogether or we'll have fixed things so that we can just zip around the galaxy and, it'll be all good.
I need to ask my stock question, though. If this planet is Earth-like and is in the Goldilocks zone and is, somewhere where life could potentially exist, what's it like standing on the surface of this one? Last week I got sucked into a void and imploded or something. But what's this one going to be like?
Well, if it's a rocky planet, and the signs seem to be that it will be, with a temperature, it's thought to be just slightly warmer than the Earth's average temperature, but still within the range which would allow liquid water to exist. I think they're saying the equilibrium temperature is between -60 and +20 degrees Celsius. So -60 at the poles, presumably 20 on the equator. It sounds perfect, really.
It does. Sounds nice.
So liquid water. Now, we don't know whether it's got water. These are observations that are yet to be made. And of course, that's one of the exciting things about the time we live in, because we're on the brink of seeing a new generation of what are called extremely large telescopes. ESO are building one of their own. That'll be the biggest telescope in the world when it comes online in about a decade. But we in Australia are already part of something called the GMT, the Giant Magellan Telescope, which is effectively a 22-metre telescope, and that will be capable of measuring the contents of the atmospheres of some of these exoplanets. So that's how we will perhaps find out, first of all, whether there is liquid water there, and maybe even whether there are what are called biomarkers, materials within the atmosphere that can only be produced by living organisms.
Yeah.
That's the kind of thing we've got to look for. Very exciting.
And that's not that far away. And once they build the gigantically enormous telescope, we'll just be able to wave, and they can wave back.
Exactly, that's right. They'll wave back. Of course, it takes 11 years for our wave to get there and another 11 for it to come back. But that's all right. We can live with that.
It'll be fine. It'll be fine. All right. Fred, as always, a lot of fun, and thank you so much.
Good to talk to you, Andrew, and keep on with those punny comments that you make from time to time.
Look, I don't know where they come from, but I've been sued so many times I just don't care anymore. And we will catch you next week. I was talking to you, Fred, but I'll talk to the audience.
I thought you were talking to the three people who are listening to this now.
Yes, including you and me.
We'll catch them next week. That's right.
Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley, thanks for listening. Thanks for supporting us. We're starting to see some really significant numbers downloading this podcast, which we greatly appreciate. So thank you so much. And please keep listening, keep telling your friends, spread it on Facebook and Twitter and Bookface and all the others. And don't forget to keep in touch via Facebook and Twitter. We love to hear from you, whether it's a question or an observation or a link. People love to send us links about things that they've found in the astronomical world. We love to hear about them too, so send us that stuff. And we will catch you next week on the podcast known as Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.